Alright guys, welcome to RC Mojo. Today we've got the Jimny back on the bench. Last time we gave it a test run out in the woods and it did really rather well considering its chassis is more suited to bombing around in a car park or perhaps even racing. One of the main issues was of course the open diffs, getting stuck every time a wheel was off the ground. A standard gear diff works well enough when there's lots of grip, but when the wheels have no grip at all the power ends up going to the wheel with the least traction, which is pretty useless when you're trying to crawl. So here we are then, the first job I'm going to do off camera. The body and chassis accumulated a lot of dead grass and leaves, so it'll need a good clean before we start the operation. We want it all fairly clean so we don't get all the grit inside the gearboxes. There we go, it's not completely spotless, but it's going to be so much nicer to deal with now. If you're the kind of person that builds kits, this is all going to be a doddle. It's not the quickest process, there's quite a bit to take apart. If you've got one of the XB versions and not built many kits, it's still doable, just take your time with it. Okay, the rear gearbox is the easiest to get into. The wheels need to come off so we can access everything. The hexes are well and truly jammed into the wheels, so keep an eye out for the drive pin just in case it falls out. It's probably a good idea to keep all the loose bits in a pot so they can't roll away, just like when we built the kit. Right, I reckon the suspension's going to need to come off, less to get in the way and more importantly less bits to drop dirt into the gearbox. The bottom of the dampers can come away and the screw pin on the bottom arm. The suspension comes away with just the top arm still attached and it'll just pop off at the ball end on the chassis. That's really opened up the chassis. Next I think the body post should come off, less to get in the way, and with the cross braces tying them together they're going to need to come off anyway. The motor needs to get disconnected, just leaving the 4 screws that connect the rear gearbox to the front half. Ah yes, on the side there's the prop shaft which also ties the gearboxes together. It'll need to come out, 2 screws on each of the covers. With this out, we now have the inside of the gearbox exposed, so we'll need to be very careful not to drop any dirt in. Anyway, with the shaft out, the last 2 screws can be removed and the gearbox will just slide away. There may be quite a few bits attached, but the modular design is still a rather nice one. We probably could have removed the gearbox and then taken the suspension apart. Might have made life that little bit easier. There's not too much left now. The damper mounts need to come off as they tie the 2 halves together. The drive cups can come out before they fall out. Motor now, just the 2 screws and the motor's going to slide out, leaving us with the 3 screws that hold the gearbox halves together. They can come out, letting us crack the gearbox open. Well, that wasn't so bad. According to the length of the clip, it took me a bit under 15 minutes to take it all apart. Would probably take 10 minutes without having to peer around a camera. Okay, the inside of the gearbox is, not surprisingly, very greasy. The grease will pick up any grit it comes into contact with, so I've put down some clean paper so we have a nice clean area to work on. Also, due to the grease, I've got a paper towel to hold the diff with, all in aid of keeping everything nice and clean. With the diff out, we need to remove the end cover, just the 3 small screws. The cap slides out, with the spider gears apparently, well they can go straight back in. There's a couple of different methods for locking these diffs. I tend to go for the hot glue method. We don't want to clean the diff out, all that grease will stop the glue sticking to the gears. It will make a plug that will lock up the diff, but if we ever want to open them back up, the glue will peel off fairly easily. It's a very simple process. Bury the nozzle between the gears and squirt a load of glue in. There's 3 gaps, so 3 lots of glue. Working fast and making sure any strings of glue get removed, pop the end cover and gear back in. If you're quick, the glue will still be warm enough so you can see everything nicely. If you do mess up, you can take it apart, clean off the glue and have another go without much issue. With the 3 screws back in, the whole lot can go back together. Diff back in the box, some screws, damper mount, suspension, making sure left and right hand assemblies end up on the right sides. It's much quicker to put it back together. You could pop the wheels on too, I suppose. There we go. If you turn one wheel, the other one spins with it. So when you've got a wheel off the ground, the truck will still make progress. The only other big bit for the rear gearbox would be the motor, but we'll deal with that later. So that's the rear more or less done, so on to the front. The front gearbox extends back to become a large portion of the chassis where the ESC mounts, and since the chassis is going to split in half, the ESC needs to be removed. With the ESC out, the switch comes off too, and since the receiver's held in with Velcro, that might as well come out as well. In other words, the electronics all need to come out except for the servo. The extension block can get removed, 4 screws, 2 on each side, and the block just slides away. The rest is pretty much the same as the rear. Wheels and body posts off, front bumper and suspension next. The drive cups can drop out and be put on the side, which just leaves us with the 3 screws holding the gearbox halves together. There's rather a lot of places for dirt to accumulate, so keep an eye out. Clean any big bits off before they find their way into the gearbox. As before, the diff drops out and we'll use some paper as a clean surface. The 3 screws come out and the cover slides off. It's exactly the same assembly as the one in the rear. Another option that's popular for locking these diffs is to remove one of the spider gears and slot it in between the 2 remaining ones. It locks the diff up well, but having the load all on one side of the gears doesn't really sit well for me. Gluing it up keeps the load nice and even. Having said that, I've not come across anybody with problems for moving the gears around, so it's a perfectly valid option. Rebuilding is the reverse of disassembly. Gearbox halves together with the 3 screws. Suspension back on, bumper on. The chassis extension slides back in with its 4 screws. The rear gearbox gets offered up and its 4 screws can go in. Access is a bit tight with the shocks fitted, but it's doable. However, refitting the prop shaft isn't going to work. We'll need to swing the shock and the hub out the way to get it in. But it's only a screw and a ball end, so it's not going to take that long. The prop shaft with its bearings should slot straight in. Just make sure the flanges on the bearings sit nicely in their slots. If they're not sitting right and you fit the covers, you'll probably damage the plastic bits. The suspension arm and damper can be refitted, leaving us with something that looks a lot like a complete chassis. Next we'll look at the motor. The torque tune Tamiya can, which for crawling around is far too fast. We could fit a smaller pinion, but not enough to make the difference we really need, so we fall back to the standard fix, a high turn motor. Here we have the wonderfully named Hack Moto Crawler from Yeah Racing. It's got an opened end bell with replaceable brushes, maybe not the best idea on a chassis where the motor sits out in the open behind one of the wheels, but it was cheap and looks cool, so I thought it was a fair compromise. If you want one, there's the part number and a QR code. No idea what's coded in it, but I'd imagine it's probably a link to the product page. Try it and see. The motor is a 45 turn, which should drop the top speed to something reasonable. It's fully ball raced, which is nice. Most of all though, the quality feels perfectly good for the application, and it looks a whole lot more snazzy than the old silver can. The only real downside for a lot of people is it doesn't come with wires. The motor has terminals that would probably fit fast-on or spade sockets, and you could probably get some with bullets on the other end, but that is a really terrible way to do it. Since we're not going to be drawing all that much current, the skinny wires on the Tamiya motor will do just fine for the new one. The heat shrink over the yellow wire needs to be carefully removed. Pushing a blade in with the sharp side up does the job quite nicely. We'll need something to stop the motor from rolling around. A nice pair of weighty pliers works well. This is something that a nice big iron or soldering gun is very useful for. We want to be in and out as quick as we can so we don't damage the motors. Get the tip up to temperature. With a gun like this it only takes a couple of seconds. Get some fresh flux solder on there and heat up the joint while gently pulling on the wire. It should come off quick and easy. Same goes for the other one. New motor now. On the end bell there's a tiny marking that shows which side is positive. That's where we'll want the yellow wire. Because we're doing the soldering, we can choose the best place to solder the wires for clearance on the chassis. The motor's going to sit in the chassis something like this, so the wires need to solder to the top terminals facing towards the front of the chassis. That noted, we need to tin the terminals. A nice coat of solder on the top surface is all you're going to need. Green wire first. Hold it over the terminal and apply the iron. As long as you haven't been holding the iron on the joints for ages, there's still going to be plenty of flux. So just heat up the joint, wait for the solder to flow, remove the iron, job done. Same thing with the yellow one. They're not the tidiest joints I've ever done, but they'll do just fine. From the Tamiya motor we'll need the pinion, and I guess we might as well use the disc thing that Tamiya likes so much. There's got to be a good reason to use it. It's been in just about every kit Tamiya have ever produced. The bearing lump on the can is quite a bit smaller on the new motor, so the disc doesn't stay in position. We'll have to be clever when fitting the motor. The pinion can slide on with a grub screw on the flat. Next, we need to set the position using the tool Tamiya provide. It sits on the top and the pinion wants to butt up against the top surface. A really neat tool. When the pinion's in the right spot, tighten up the grub. Right, we can't fit the disc to the motor and offer it up as it will just fall about. So I'm going to pop the motor screws through the gearbox and hang the disc on the exposed threads. Then very carefully offer up the motor while holding the screws in with a screwdriver. Do up the screws so nothing can fall out. Well, that worked. Nice. Mesh setting next. We want to adjust the motor so there's just a small amount of slot between your pinion and the next gear. It's hard to pick up on camera, but in that inspection hole above the metal plate you can just about see the gears moving. When it's all set up, the cover can go on. Well, we're really close now. We can refit the wheels. Remember the hexes got stuck in the wheels, so we need to refit the drive pins too. After fitting all four, we have what looks a lot like a rolling chassis. Yeah, definitely a rolling chassis. Next is a fiddly bit. The electronics need to get refitted. Now, I'm just going to jump cut it. If you want to see the install in more detail, the original build videos cover it all. There we go then. All that's left are the body posts. One screw per post. All are just about accessible with the wheels on. And there's the antenna tube. A bit fiddly to thread through, but there we go. Done. Well, I suppose we should turn it on and make sure it all works. Well, it arms okay. And it goes. Nice. That's the first step. Well, two steps if you count the diffs and the motor separately, on the conversion to a scaler. There's still a lot to do. For a start, it really needs a set of oil dampers. The steering still binds up the front drive shafts, not to mention lights. Lots to look forward to, yes. And that brings us to the end of this week's video. I hope it wasn't too disjointed. I was trying to balance between a complete screw for screw instructional and a more general guide. Either way, I hope you enjoyed. If you did, it's always greatly appreciated if you hit that like button. And of course, if you want to know when we upload the next video, you can of course subscribe. It's completely free. So, thanks for watching. Bye guys.